example X1, when we see this and we see that they've got two different trig functions, we know we're not going to be able to isolate, and you can also tell you're not going to be able to factor. So what we want to do is we want to square both sides. I'm going to end up using the identity tangent squared x plus 1 equals secant squared x, and we've seen this before in another example, but that's what we need. Okay? Now, I'm going to square both sides, but you don't want to just square both sides as is. Something kind of strange happens when you try to square a tangent and a secant on the same side. You end up with tangent squared plus 2 tangent secant plus secant squared. You've got an issue. You've got an issue where you'll still have a tangent and a secant. I'm trying to get to a situation where I only have one or the other. Okay? And so long story short, I want to get this to the other side. You want to separate the two functions so they're on opposite sides from each other. Tangent 3x equals 2 minus secant 3x. I want to square both sides. So on the left, we'll have tangent squared 3x equals, and I'm not going to show the work to FOIL this out just because I want to save time. If you square this, it's not as simple as distributing the 2. You can't distribute the exponent. You're going to have to expand and FOIL it out. You're going to end up getting 4 minus 4 secant 3x plus secant squared 3x. And again, if you don't know where that came from, then just expand it and FOIL it out. Okay? So we can use this identity, and the last time we used it, we said secant squared was equivalent to tangent squared x plus 1. And so we would have done a substitution right here. But the problem with that is I'll still have a tangent and a secant. I'm trying to get to a situation where I only have one trig function. And so that's not exactly what I want to do. In this case, I'm going to isolate for tangent x. I'm going to subtract 1, and I would have tangent squared x equals secant squared x minus 1. I'm going to do a substitution over here. Okay? Yes, that's supposed to be 3x in this case. But I'm going to say that tangent squared 3x is equal to secant squared 3x minus 1. And so bring down the other side, equals 4 minus 4 secant 3x plus secant squared 3x. Okay. So at this point, we've only got one trig function, which is much better. But even better than that, you maybe would notice that the secant squared is going to cancel itself out. And so I've got something pretty good. I've got an equation with only one variable function. And anytime we have one variable function, we ought to be able to isolate. Okay, so we can isolate here, subtract 4, you get negative 5, equals negative 4 secant 3x. Divide by this negative 4, and I've got 5/4 plus you, equals secant 3x. Okay. So it's kind of hard to do an inverse secant. That's what we'd have to do next, inverse secant, to cancel out the secant. So what I'm going to do is I'm going to take a reciprocal function and look at this in terms of cosine. The reciprocal of secant is cosine, and so take the reciprocal of both sides. I have cosine 3x equals 4/5. So at this point, I'm going to do an inverse cosine to get rid of that cosine. And so we're going to want a calculator, I believe, for that. Okay, let's make sure we're in radians, because we have to be in radians there, like it says. But we know 3x is going to equal inverse cosine of 4/5. That's not a chart question. That's how I knew it was going to have to be on the calculator. Inverse cosine 4/5. This point, let's just call that 0.64 to save time. 3x, well, I guess that's not 3x yet, I guess. Really what we've got is a reference angle, okay? What we just did, when we solved this, okay, when we're trying to find that angle, we found a reference angle, I know it's kind of hard to understand when it's not in degrees, but that is a reference angle, 0.64. 0.64 where cosine is positive. And so your 0.64 where cosine is positive would be in your first and your fourth quadrants, okay? And so one of those answers is just 0.64, but the other one, you'd have to go all the way around, not quite all the way around anyway, to 2 pi. We should be able to subtract. It's 2 pi minus that 0.64. If I do 2 pi minus 0.64, I'm going to get a decimal 5.64%. So this over here, this angle over here is 5.64. That's my second. Now, when we've done these problems in the past, a lot of times we're finished. But we're not finished because we haven't found x yet. That was 3x. When we did the inverse cosine, we were trying to isolate x, but we only got 3x. Our last step is going to be divide by that 3. Okay? But one of the trickiest parts about this problem is something that you're going to have to make a point of remembering to do. But when we did the inverse cosine, you should have noticed that that's a tripled angle. Okay? That 3x means that angle is tripled. And so what ends up happening is I have to triple the interval. So just kind of remember it. Triple the angle, triple the interval. And what that means is I get to go around 3 times. You're not just going around once. You're going around 3 times. And so what that means is this angle right here, this 0.64, I would go around again. Let's add, not 360, but 2 pi in this case. I'm going to add 2 pi because I get to go around again. So calculator, I'd have 0.64 plus 2 pi is 6.92. Okay? So keep in mind I'm rounding off just to try and make this a little bit easier on you. But anyway, we also had this angle right here, which was 5.64. If I get to go around again, you're going to add 2 pi. And that's 11.92. So at this point, I've gone around twice. Okay? I get to go around a 3rd time. So let's go around again. We're at this angle. Well, where I was 6.92. Once I went around the 2nd time, I was at 6.92. So take that 6.92 and add 2 pi. That's 13.2. And then do the same thing for this. Okay, it was 11.92 once I went around the 2nd time. So going around the 3rd time, you would add another 2 pi. And we get 18.2. Okay, 18.2. All right. We've gone around 3 times, but we still haven't isolated x. The last step is always isolate x. We're going to divide by 3 to isolate x. So divide everything by 3. So 0.64 divided by 3 and 5.64 divided by 3. So keep in mind I've rounded off, but I've got x equals 0.21 about and 1.88 about, and then 6.92 and 11.92. We've got 2.31 and 3.97, and then we've got 18.2 and 18.2. So we have 4.4 and 6.07. Okay. Now, if only we were finished, okay? It looks like we're finished, but we're not because we've got this problem of when we square both sides. Okay, anytime you square both sides, you're creating extra solutions. And we talked about this the other day, I think. But if I said x equals 4 if we squared both sides and got x squared equals 16, the solution to that equation is plus or minus 4. So if something strange happens when you square both sides, that you add this extra solution on there that wasn't supposed to be there. Okay? And so that has happened, and what that means is you're going to have to plug all of those in on the calculator. Okay? And so that's where the next slide comes in. The next slide shows you that they've done that. Okay? When they plugged in 2.145 or 0.2145, is that one of our numbers? Yeah. Okay. They plugged 0.2145 in and got, basically that's 2. Okay. When a calculator is really, really, really close to a number, sometimes it's just rounded off. Okay. If you look back at the original equation was this. And so what they've done is they've plugged in that 0.2145 number into the original equation, and they got 2, which is exactly what they wanted to get. Okay? So when they got 2, that worked. And so that's how I know that this 0.21 number works. Okay? But if you look, when they plugged in, the next one was 1.8799. They got 0.5, and 0.5 isn't going to work. Okay? So that means, oops, that this number right here is extremes. This one doesn't work. Okay? When you plug in those numbers, anytime you get 2, that one worked. If you don't get 2, that one doesn't work. So 2.3 worked, but 3.9 did not work. 2.3 works, 3.9 did not work. And then they keep going, they plug in 4.4 and it works, and 6.0 did not work. 4.4 worked, 6.0 did not work. And so you have to do that. When you square both sides, you have to do that and figure out which ones don't actually work. We found that those 3 do. And there's your